So the next topic we're going to discuss here is wildcards in Java for generics. And wildcards are kind of a difficult concept to explain here. I've changed our project up a little bit to save some time. I've created a new method here called print1, and I've modified our printer class. What I did here is I took out our bounded type, so printer is now unbounded. Printer can accept any type T. And the reason for this is because wildcards are going to be used in a situation where you might not be able to bind T or set a bounded type inside of a class. For example, let's say that printer was not a class we created, or we didn't have the source to it, and printer took any type T. But we wanted to do something with all kinds of printers. So we wanted to create some method that operated on all kinds of printers that took print cartridges, for example. We need to be able to do that, but we don't have access to that source code. So this is where wildcards can help us here. So you might think that a way to do that is in this print1 method that I have created here, that we are going to pass in a printer and we're going to call getCartridge. I created a getCartridge method on printer in order to get the cartridge that's currently set to the printer. And then we would call our getFillPercentage and be able to print that out. Now there's a problem here, which is, first of all, that just using printer without a generic at all, it doesn't know that we have this getFillPercentage. Because printer, the getCartridge that comes back, isn't going to know anything about this. If you look here, since printer can be of any type, that means that what getCartridge can return can be of any type. And so in this case, we are restricted down to the same methods that exist on all types, or that exist on object, for example, which getFillPercentage is not one of those. So somehow we need to specify that the printer that we're going to pass in is of a type of iCartridge in order to be able to call this getFillPercentage. So you can see I've declared two printers up here, a printer and a printer2, and one has a black and white cartridge and one has a color cartridge. So both of them are types of printers that implement iCartridge. So we might think at first that we could just do this, printer of type iCartridge. And now we can actually call getFillPercentage, but there's a problem here. If you look at the print1 method call, there's an error here. It won't let us pass in a printer. Because in Java, printer of type iCartridge, even though iCartridge is implemented by BW cartridge and color cartridge, printer BW cartridge is not a child. It does not implement printer iCartridge. It's a totally different thing here. In some languages, this would be the same. You could say printer iCartridge, and printer BW cartridge would be a type of printer iCartridge. And even though this conceptually makes sense and it seems like this should work, it doesn't work in Java. And part of this is because of another topic we're going to talk about next, which is because of erasures. But regardless of that, we need some way to specify that our method is going to take any printer that extends iCartridge. So any printer that T is of iCartridge. And if we were able to use a bounded type before, we had done this in the previous example, but in the instance where we can't control our type from inside printer because maybe we don't have access to the source code, we need a way to basically declare printer iCartridge. The way that we do this is with wildcards. If we were able to change our class here, if you remember, we would have just said printer extends and then iCartridge. But we can do kind of the flip side here, and we can use a wildcard. We use this question mark extends iCartridge. And what this means is it just means that this variable will hold any type that is of printer but is of type iCartridge. So whatever the T is that we pass into the printer, as long as it extends iCartridge, then this variable will be able to hold it. And this allows us to basically pass into this parameter either a BW cartridge or a color cartridge. And then we can actually use the getFillPercentage on that because, again, it's working just like we had with the bounded types, where we knew that because we've restricted the type for printer down here, that we know that the methods that are on iCartridge must exist. So one thing a lot of developers fail to realize about generics in Java is that they use type erasure. And type erasure is just a fancy way of basically saying that generics are not real. And what I mean by that is once you compile your Java application, the generics are not in the bytecode. They're not in the code that is run in the JVM. So this is kind of a strange concept to understand here, but what essentially happens is the compiler uses generics. And the compiler uses generics to determine if something's wrong or right. If you can, when we showed the example of adding the wrong type to a house, it would tell you that and give you an error. But once the code is compiled, those generics are stripped out. They're erased, essentially. And everything is essentially an object. We had seen that example of the house earlier in this module where we had not used generics. Well, after you've compiled your code, it basically reverts to that. The bytecode, if you looked at it, would look just like the first example where it was dangerous. The generics made it so that the compiler was able to help us and ensure that we never tried to put the wrong type in our house. But it doesn't need that anymore afterwards. And this is different than a few other languages that have features similar to generics. For example, if you're familiar with C#, C# has true generics. They're not erased at compile time. They actually exist in the bytecode. If you looked at the code that runs in the virtual machine that .NET code runs in, it actually has generics in there. And if you know about C++, in C++, actually code is generated. It's actually a template, is what C++ uses, and code is actually generated that is of that type, or it takes that class and actually generates real code that operates on that type. It's creating new classes for you automatically. So those are real and they exist in that sense. But one of the things to be aware of in Java because of this is that generics are going to behave a little bit differently than what you might expect. You're not going to be able to do a lot of things with generics that you might want to do. For example, if you're in a generic method or a class that's using a generic, you can't check the type of that generic. If you had some generic type T, you couldn't ask, is this type, what is the type? Because it doesn't exist at runtime, so you can't check the type at runtime. Remember, it's going to be of type object always because that type got erased. The same goes for creating a new instance of that type. If you got a type passed in or you had a house of type dog, you couldn't, inside of your class, do a new T, or new, which would be new dog, because Java doesn't know about that at runtime, so it's not going to be able to utilize that type. And rather than listing out all the scenarios in which it will cause a problem for you, I think it's better for you to just understand this. So when you're thinking about using generics in Java and whether or not something is legal in Java, just think about what would happen if this code was compiled and the types were changed to object. If you use that as a guideline, then you'll be able to figure out scenarios where you're not going to be able to do something with a generic. For the most part, you're probably not going to run into this very much, but if you're trying to do something fancy with a type inside of a generic method or a generic class, and you're trying to examine what the type is, that's where you're going to run. So let's go over what we covered in this module. Well, we went through and we talked about what a generic is, which is basically just a way of writing some code that's independent of a type. And we found out that we could do this in a class and we could do this in a method. So I showed you how we could create a generic class, and we created a generic class so that we could specify what type we wanted to use and reuse that class for a whole bunch of different types. Then we went through and we did the same thing and created a generic method, a method that could be used and operate on multiple kinds of types. And then I showed you some examples of bounded generics. We learned that bounded generic is a way to restrict your generic so that whatever type is being passed into that generic method or that generic class has to extend or implement a certain interface or class. Then we looked at the special case of wildcards in generics. And this is one of the more complicated features that exists in Java for generics. And we talked about how you could use a wildcard to represent almost a generic type, a type that would either represent a whole class of types, any types of generics that would inherit from whatever the type is, or any classes that were a parent of whatever the type is. And then finally we talked about how generics are implemented in Java, that they use type erasure, which is basically means that when the code is compiled, the generics are gone. They disappear from the code. And I gave you a little bit of caution that you should remember this when using generics in Java, and to basically just think about when this code's compiled, if the type changed to object, would the code that I'm writing work? Because that's what's going to happen when your code is compiled. So that's the end of this course on Java fundamentals. You should now have a pretty good understanding of the basics of Java. And the second part of this course, in the second course on Java, we're going to cover some more advanced topics that are still fairly basic, but will help expand some of the usage of Java. But at this point, you can pretty much understand Java code and should be able to write Java code that is able to accomplish some simple goals. And we've really covered most of the language features that exist in Java, or at least most of the basic ones that you'll use on a day-to-day basis. Well, thanks for joining me on this course, and I hope that you've learned a lot about